Betelgeuse remains one of the most captivating astronomical objects in the night sky, not only for its staggering size and brilliant luminosity but for the profound questions it raises about the life and death of stars located roughly 650 light-years away in the constellation Orion. Betelgeuse is a red supergiant, a stellar class that represents one of the final stages in the evolution of massive stars with a radius hundreds of times that of the Sun. If Betelgeuse were placed at the center of our solar system, its outer layers would extend beyond the orbit of Jupiter. Such immense scale is difficult for the human mind to fully comprehend, yet it's precisely this vastness that makes Betelgeuse such a critical target for astronomers seeking to understand how the universe recycles matter and energy. The peculiarities of Betelgeuse behavior have made it a star of intense scrutiny, especially over the past several years. In late 2019, Betelgeuse underwent a historic dimming event, dropping in brightness by nearly 40%, leading many observers to wonder if it was about to explode as a supernova. While such a cataclysmic event would not pose any danger to Earth due to Betelgeuse distance, it would be an unprecedented spectacle, a once-in-a-lifetime light show, potentially visible even during daylight. However, detailed studies soon revealed that the dimming was not a sign of imminent explosion but rather the result of massive dust clouds expelled from the star's surface. These clouds, when viewed from Earth, obscured Betelgeuse's light, making it appear fainter. This episode highlighted how dynamic and turbulent the late life of a red supergiant can be. Betelgeuse is constantly shedding mass through powerful stellar winds and violent surface convection, which can produce enormous plumes of gas and dust. These processes are crucial for seeding the interstellar medium with heavy elements, the raw ingredients for future generations of stars and planets, the calcium in our bones, the oxygen we breathe, the iron in our blood, all were forged in the nuclear furnaces of massive stars like Betelgeuse and then spread across the galaxy through supernova explosions. Yet, for all we have learned, Betelgeuse still holds countless secrets. Astronomers are using every available tool to probe its internal structure, hoping to unlock the mysteries of its fate. Advanced astroseismology, the study of stellar oscillations, allows scientists to listen to the star's internal rumblings, providing clues about the processes occurring deep beneath its visible surface. Meanwhile, high-resolution imaging from instruments like the Very Large Telescope Interferometer has given us unprecedented views of Betelgeuse turbulent surface, revealing bright hot spots and massive outflows of material that hint to the chaotic forces at work. The James Webb Space Telescope (JWST) has opened a new frontier in the study of Betelgeuse with its powerful infrared vision. JWST can peer through the dust that obscures visible light, revealing the star's inner workings with astonishing clarity. Already, observations have provided new insights into the temperature variations across Betelgeuse surface and the composition of its ejected material. By studying the dust and gas surrounding the star, astronomers can better understand how red supergiants lose mass in their final stages and how this material interacts with the surrounding interstellar environment. But why is Betelgeuse's eventual explosion so important? For one, it offers a rare opportunity to study a nearby core collapse supernova up close. Supernovae are among the most energetic events in the universe, releasing more energy in a matter of days than our sun will emit in its entire lifetime. These explosions play a crucial role in galactic evolution, dispersing heavy elements and triggering the formation of new stars. Yet, despite their importance, many aspects of the supernova process remain poorly understood. Models struggle to fully account for how the core collapse leads to an outward shock, how neutrinos drive the explosion, and how asymmetries in the blast affect the resulting neutron star or black hole. Betelgeuse, when it does go supernova, will provide an unparalleled laboratory for testing these models. Astronomers across the globe are preparing networks of telescopes, neutrino detectors, and gravitational wave observatories to capture every possible detail of the event. Early warning systems such as the Supernova Early Warning System (SNES) are designed to detect the burst of neutrinos that will precede the optical flash by several hours, allowing scientists to aim their instruments at Betelgeuse in time to catch the explosion's first light. Yet the supernova itself is only part of the story. The aftermath, the nebula that forms from the expanding debris, the compact remnant left behind, will offer decades, if not centuries, of scientific discovery. If Betelgeuse's core collapse leaves a neutron star, astronomers will have the chance to study its pulsar emissions and magnetic field. If it forms a black hole, we will gain direct evidence of how stellar mass black holes are born. Either way, the chemical fingerprints left in the supernova's ejector will tell us about the nuclear processes that occurred in the star's final moments, enriching our understanding of stellar evolution and nucleosynthesis. But beyond the scientific stakes, Betelgeuse's story resonates on a deeply human level. For thousands of years, civilizations around the world have looked up at Orion and marveled at its bright shoulder. Betelgeuse has been a constant fixture in myth and legend, a symbol of strength, change, and impermanence. The idea that this familiar star is nearing the end of its life serves as a poignant reminder that nothing in a universe is static, that even the brightest, most enduring lights will one day fade or explode. This cosmic drama reminds us of our own place in the universe. We live in a moment of cosmic history when we can observe, understand, and appreciate these grand cycles. Just a few centuries ago, people would have interpreted a bright new star in the sky as an omen, a supernatural event beyond explanation. Today we understand that it is the death cry of a massive star, a natural part of the universe's ongoing dance of creation and destruction. This understanding does not diminish the awe we feel. If anything, it deepens it, connecting us to the vast, intricate web of processes that shape the cosmos. Moreover, the study of Betelgeuse and other massive stars speaks to the incredible ingenuity of human beings, from ancient sky watchers charting the constellations to modern scientists building multi-billion-dollar observatories in space. We have always been driven by a desire to know more, to push the boundaries of our understanding. Observing Betelgeuse is an act of both science and wonder, combining the rigorous discipline of astrophysics with a timeless human urge to gaze upward and ask what is out there. As we await Betelgeuse's final act, we are reminded of the delicate balance that governs the cosmos. Massive stars live brief, violent lives, yet in their death they give rise to new stars, planets, and the conditions necessary for life. The atoms in our bodies, the carbon, nitrogen, oxygen, were forged in the hearts of long-dead stars and scattered across space by ancient supernovae. When Betelgeuse explodes, it will add its unique chemical signature to the galaxy, contributing to the cosmic cycle that may one day give rise to new life somewhere else. The anticipation surrounding Betelgeuse's fate is a testament to the power of curiosity and the enduring human connection to the stars. Whether the supernova happens tomorrow, in 1,000 years, or has already occurred and its light has yet to reach us, the story of Betelgeuse captures something fundamental about our relationship with the universe. We are small, fragile beings living on a tiny planet orbiting an unremarkable star, yet we have developed the tools and the insight to understand the grandest of cosmic events. We are quite literally the universe becoming aware of itself, so we continue to watch Betelgeuse night after night, season after season, knowing that one day the sky will change. When that happens, we will bear witness not just to the death of a star but to the continuation of a cosmic legacy, billions of years in the making, and in that moment we will be reminded that we too are part of the stars, woven from their remnants and destined to share in their eternal cycle of birth, death, and rebirth. As we wait for Betelgeuse's eventual supernova, it's worth reflecting on the profound scientific preparations already underway across the world. This star, once just a bright point of light to ancient sky watchers, has become a focal point for cutting-edge astrophysical research. Scientists are not simply standing by passively, they are actively preparing an unprecedented observational campaign. The coordinated use of ground-based telescopes, orbiting observatories, neutrino detectors, and gravitational wave instruments will allow us to capture the moment of Betelgeuse's death in exquisite detail. Neutrino observatories, like Super Cameo Candy in Japan or Ice Cube in Antarctica, are tuned to detect the flood of ghostly particles that will pour out of Betelgeuse's core in the moments before it collapses. Gravitational wave detectors like LIGO and Virgo stand ready to catch the ripples in spacetime generated by the collapse, offering a window into the most extreme conditions nature can create. On the optical and infrared front, the James Webb Space Telescope JWST will play a critical role. Its unmatched sensitivity will allow astronomers to track the supernova shock breakout, observe the expanding blast wave, and analyze the chemical composition of the ejected material. Meanwhile, telescopes like the Hubble Space Telescope, the European Extremely Large Telescope ELT, and the Vera C. Rubin Observatory will provide complementary data across multiple wavelengths. Together, this global network will deliver the most detailed record of a supernova ever captured by humanity. This is not just an academic exercise, it is a rare chance to test theories about quark supernovae that have until now been based largely on distant, unresolved events in faraway galaxies. There's also a compelling public fascination surrounding Betelgeuse. When news first broke of the star's dramatic dimming in 2019, social media lit up with speculation, memes, and amateur observations. Planetariums and science centers saw a surge in public interest, with people eager to learn more about this enigmatic red supergiant. The idea that a star visible to the naked eye might soon explode captured the imagination of millions. This enthusiasm speaks to the deep, almost instinctual connection people feel to the night sky, a connection that transcends culture, language, and generation. Betelgeuse has become a cosmic celebrity not just among scientists but among everyday stargazers and dreamers. What will the supernova look like when it happens? Based on models, Betelgeuse's explosion could outshine the full moon for several weeks, becoming visible even during the daytime. At night, it will transform Orion's familiar outline, turning the constellation Shoulder into a brilliant beacon. Astronomers estimate that Betelgeuse's peak apparent magnitude will fall between -10 and -12, making it one of the brightest objects in the sky. Apart from the Sun and the Moon, such a bright supernova has not been seen from Earth since when Johannes Kepler observed the last naked eye supernova in the Milky Way. For those lucky enough to witness it, Betelgeuse's explosion will be a once-in-a-millennium spectacle, but after the fireworks fade, the real work will begin. The expanding remnant of Betelgeuse will offer astronomers a long-term laboratory for studying supernova aftermaths in detail. We will be able to track the evolution of the shock wave as it interacts with surrounding material, mapping the structure and density of the interstellar medium in unprecedented ways. Over decades, the nebula left behind will blossom into a complex web of glowing filaments rich in heavy elements that will one day become part of new stars and planets. Future generations of astronomers will continue to mine this event for insights using technologies we can only imagine today. Interestingly, Betelgeuse's story has also sparked new questions about the diversity of massive star deaths. Not all red supergiants go supernova in the same way. Some may quietly collapse into black holes without a bright optical display, a phenomenon known as a failed supernova. Others might undergo unusual outbursts or eruptions before their final collapse. By studying Betelgeuse and comparing it to other massive stars, scientists hope to unravel the factors that determine a star's final fate, whether it dies with a bang or a whisper. The potential formation of a neutron star or black hole at Betelgeuse's core adds another layer of intrigue. Neutron stars are among the densest objects in the universe, packing a sun's worth of mass into a sphere just 20 kilometers across. They possess mind-boggling magnetic fields, spin rates, and exotic states of matter that challenge our understanding of physics. If Betelgeuse leaves behind a neutron star, astronomers will have the rare chance to study a fresh nearby pulsar as it emerges from the wreckage. On the other hand, if the star's core is massive enough, it may collapse directly into a black hole, giving us valuable observational evidence of stellar mass black hole formation, a process that until now has largely remained hidden. There's also the subtle but profound awareness that even as we anticipate Betelgeuse's death, we are looking into the past. The light we see from Betelgeuse today began its journey roughly 650 years ago, long before telescopes existed, during a time when medieval civilizations still dominated Earth. If Betelgeuse had already exploded, the light from that event would still be making its way to us across the vast interstellar gulf. In this sense, Betelgeuse is a cosmic time capsule, its flickering light carrying the echoes of a bygone era. Looking ahead, the study of Betelgeuse is helping to shape the future of time domain astronomy, a field focused on capturing transient, rapidly changing events in the universe, from supernovae to gamma-ray bursts, from gravitational wave mergers to fast radio bursts. The universe is alive with fleeting, dramatic phenomena. Betelgeuse serves as a training ground, honing our ability to react quickly, coordinate across observatories, and extract maximum information from transient events. It is preparing us not only for its own supernova but for a future filled with discoveries we can scarcely imagine today. In the end, Betelgeuse reminds us of the incredible beauty, complexity, and impermanence of the cosmos. It is a reminder that even the most massive, seemingly eternal objects are subject to change, to decay, to transformation. Yet, from that transformation comes renewal, the creation of new stars, new planets, new possibilities for Earthbound observers. The eventual death of Betelgeuse will be a moment of cosmic significance, a once-in-human history event that ties together science, wonder, and the timeless human impulse to look up and ask questions. And when that day comes, we will watch not just as passive spectators but as informed, curious beings, children of the stars, bearing witness to the death of one of our cosmic ancestors. The study of Betelgeuse is not just an investigation into the fate of one giant star but a window into the very processes that shape the cosmos. Each pulse and shimmer of its red surface echoes the larger story of stellar life cycles, from birth and dense molecular clouds to death in fiery supernovae. These stellar deaths are not merely endings but also beginnings, scattering heavy elements across the interstellar medium, enriching the raw material for new stars, planets, and potentially life itself without the explosions of massive stars like Betelgeuse,